All right, so we're going to be looking at some reflection rules and rotation rules. So the first one we're going to look at is what happened when we reflect over the line y equal x. So if you have a point, x comma y, and you reflect the point over the line y equal x, the new coordinate is going to become y comma x. So just notice that the coordinates switch position. So you have xy, it becomes yx. Now we're going to look at what happened when we reflect over the x-axis. So when we reflect over the x-axis, if you have a point x comma y, and you reflect it over the x-axis, the x coordinate will become the same, and you become the y becomes the opposite. Opposite meaning this y coordinate is positive, then the other one is going to be negative. Or if this was negative, then the other one is positive. Now we're going to look at reflection over the y-axis. So what happened when you reflect over the y-axis? If you have a coordinate x comma y and you reflect it over the y-axis, the x coordinate becomes the opposite and the y coordinate remains the same. So notice that my x was positive. Over here, it is now negative. And of course, the y coordinate remains the same. Now we're going to move on to rotation. If you have a point and you rotate it 90 degrees, CC means counterclockwise. And counterclockwise is going to be this direction. So all of these rotation rules is for counterclockwise. So if you have a point x comma y and you rotate it 90 degrees counterclockwise, the coordinates are going to switch position, and then you change the sign of the first. So all I did was I switched, so I have now y comma x, and then I changed the sign of the first one, which in this case the first one will become like the y. Okay, now this should have been 180. So I'm going to scratch this. This is supposed to be 180 degrees. So what happened when you rotate 180 degrees counterclockwise? If you have a point x comma y and you rotate it 180 degrees counterclockwise, then that is going to be negative x comma negative y. So the order remains the same. We still have the x in the first order and the y coordinate in the second order. However, you can notice that the signs are opposite. So if this was a positive x, it becomes a negative x. If this is positive y, it becomes negative y. And then we're going to do rotation. What happened when you rotate 270 degrees counterclockwise? So if you have the coordinate x comma y, it becomes, so again you're going to flip y comma x. After you flip, you change the sign on the second one. So we're going to be using these today to help us to work some transformation problems. So let's move on to slide 2. Okay. It says rectangle A, B, C, D, and this is the rectangle A, B, C, C, D is shown on the coordinate grid. If rectangle ABCD is rotated 90 degrees counterclockwise about the origin and then dilated by a scale factor of 2 with the origin as the center of dilation, which graph represents rectangle A prime prime, B prime prime, C prime prime, D prime prime? So this, you have to ask yourself which one is the original. So rectangle A, B, C, D is the original and these are the after. How do you identify the original? Notice when you have the original, the letters are written without the prime. Look at this one. Notice how you have the letters represents with the letter prime. So that's how you can tell. So these is called the prime. The little mark is called prime. So these are the after. After you have done the transformation, this is what your result would be. So again, you have to make sure you know which one is your pre-image, which I call the before, and which one is your image, which I call the after. So this is the before, this is the pre-image. So to the pre-image, some transformation was done. And the transformation that was done is that it was rotated 90 degrees counterclockwise. So we're going to highlight that. The second transformation that was done is that rectangle ABC was also dilated by a factor of 2. So 2 transformation took place. Rotation 90 degrees clockwise. I'm going to write that down. So they rotate 90 degrees counterclockwise. So what is the rule for rotating 90 degree clockwise? If you have the coordinate x, comma, y, it becomes y. So you flip it around, y, comma, x, and then you change the sign of the first. All right. And then what does it mean to dilate by a factor of 2? To dilate by a factor of 2 means that you're going to take the coordinates and multiply it by 2. So let me show you what I'm speaking of. So you're going to take the coordinate. So where it says dilate by 2, you're going to take the coordinate x, comma, y. And you're going to take the x coordinate and you're going to multiply it by the number 2. Then the y coordinate, you're going to multiply by the number 2. Okay? Now, you could do each point, but that's going to take a longer time. So for exam purposes, you only need to choose one point. So you always choose a point again from the before. So I'm going to write before. So this is my before. Okay? So you choose any point. You can choose point A, point B, point C, or point D. In this particular example, I'm going to choose to work with point A. All right. So I'm going to choose point A. Again, you can choose any point that you want. So I'm going to choose A. So if I choose A, I need the coordinate of A. So I'm going to choose point A. So A has coordinate -4. So -4 is right here. That's the x coordinate. And -1 as the y coordinate. Okay? So 0, -1, -4. So after we have done these 2 transformation, we're going to see which of these, we're going to look at which of these have the A prime prime. So we're looking at the A. So let me just write, I'm going to circle my A prime prime here. So for this one, the coordinate for that one is going to be -2, 8. For this A prime prime, the coordinate for this one is going to be 2, -8. And for this one, A prime prime, the coordinate is -8, 2. And for this A prime prime, right here, the coordinate is 8, -2. So we're going to go up here. We're going to take this coordinate and we're going to perform this and then this. Okay. So we're gonna, the first thing that we have to do, you have to rotate first. So I'm gonna take this, which is my A, I'm gonna have it right here, -4, comma, -1. Now when you rotate that, it's gonna look, we're gonna apply this to it. So we're gonna flip it around. So we're going to have -1, comma, -4. So I flip it around. That's the only thing I did. But notice that we changed the sign on the first one. So if you notice that this was a -1, it's now going to become a +1. So I'm going to erase my negative. And this would be our A prime, sorry. So again, we flip it around, notice that the y changed. So my y right here, it was positive. Over here, it becomes negative. In this one, my y is negative. So over here, it would now be positive. So now we're going to take this A prime, which is 1, comma, -4. And we're going to dilate it to get A prime prime. So we're going to dilate it to get A prime prime. Now it says we're going to take the x coordinate and we're going to multiply it by 2. So my x coordinate is going to be number 1. And then I'm going to multiply that by 2, comma. Then you take the y coordinate. In this case, the y coordinate is -4. And then you're going to multiply by the same 2. Okay, so we're going to work that out. What is 1 times 2? 1 times 2 is going to be 2, comma. -4 times 2 is going to give us -8. And this is the A prime prime that we are looking for. So I'm going to highlight it. This is the one that we are looking for. So we're going to go back down here. Look at this A prime prime. Is it that one? No. So it's not going to be A. If you look at this one, it looks like B. Notice I have my 2, -8, 2, -8. So the answer is going to be B. So the answer is B. All right. Slide 3. It says triangle ABC is reflected over the line y = x, over the x-axis, and then over the y-axis. The results has vertices at A prime 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 4, 7, B prime 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 10, -3, and C prime 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 -6, -8. What were the original coordinates of vertex A? So here we see a series of transformation that took place. The first one was that ABC, it was reflected over the line y = x. That's the first transformation. After it was reflected over the line y = x, it was further reflected over the x-axis. After it was reflected over the x-axis, it was further reflected over the y-axis. So I'm going to write down all of those. So this is reflect over y = x. Now, if you recall, when we reflect over the line y equal x, if you have a point x comma y, you just switch position. So it's gonna become y comma x. Okay? And then when you reflect over x-axis, if you have a point x comma y, the x remains the same, and you change the sign of the y coordinate. And that's what happened when you reflect over the x-axis. And then we're going to write down what happened when you reflect over the y-axis. So when you reflect over the y-axis, you're going to have x comma y. The x is going to now become opposite, and the y coordinate remains the same. Okay? So now let's go back to the question. All of these, a prime, 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 these are the result. As it says, that's the result, meaning those are the answers. So these would be the answers after those transformations have taken place. So the question is asking us, what is the original? Original here means the before or the pre-image. And they're only asking for vertex A. Okay? So what would have been the before for vertex A? So let's highlight that. They only want vertex A. Now, if you go back, this is the answer that we're looking for. For vertex A, we're looking for this. So what we have to do, which one of these coordinates represents the original A? Is it this one, this one, this one, this one? Please don't be confused and think that A, B, and C represent these numbers down here. No. All of these coordinates is just saying which of them would represent A. Is it this one, this one, this one, or that one? So we're going to go from using option A. So let's start with the first answer choice, A. So answer choice A, does that represent our first A? So I'm going to write it down. So this is just the answer choice. So it has -4, -7. So we're going to take the answer choice and we're going to perform the reflection and then over the y equal x and then the x-axis and see if the answer that we got match this one. Okay? So it says -4, -7. Now, if we reflect that over the y-axis, just flip the coordinates around. So -4, -7 is going to become -7, -4. And this would be our A prime. We have 1 prime because that's the first transformation. Now we're going to take this A prime. Let me use the color red. So this is our now A prime. So we're going to take that A prime, which is -7, -4. And then we're going to reflect it over the x-axis. Now, when you reflect this over the x-axis, the x remains the same. So I'm going to have -7. So the x is the same. And then the y, you change the sign. So it was -4. It's going to become +4. Okay? Oh, sorry. The y is the same. So what we did was the x remains the same. So let me see. The x remains the same, and then we change the sign of the y. So if it is negative, it's supposed to be positive 4. Sorry. Positive 4. Now that's going to be our a prime prime. A prime prime. Now we have one more to do. We're going to now take our a prime prime, and we're going to reflect our a prime prime over the y axis. So for our a prime prime, it's going to be negative 7, comma 4. Now you reflect that over the x-axis, so notice that the x-coordinate changes from positive to negative, and then the y remains the same. So with that, we're going to have positive 7 and positive 4. And that would be the a prime prime if we use this one. Now let's go back up here. Does that match what we're looking for? No, this is 4, 7, but then we have 7, 4. So you'll see that that is not the answer that we want. So A would not be the answer. So I'm going to eliminate option B. Now let's try I'm going to eliminate option A. Let's try option B. So what if that one is our A? So just like before, we're going to write it down. So option B has negative 7, comma, negative 4. So we are that's option B. So now we're going to do or reflect it over the line y equal x. So again, we're going to flip that around. So we're going to have negative 4, comma, negative 7. And that is going to be our a prime. Okay, so we're gonna take that a prime, and then we're going to have negative 4, comma, negative 7. And we're going to reflect it over the x-axis, which means that the x remains the same. So we're going to have negative 4, and then we change the sign of the y, so positive 7. Okay, and then that would be our a prime prime. And then we're going to take our a prime prime. I don't have enough space. Well, can I make it here? A prime prime, which is negative 4, comma, 7. And we're going to reflect it over the y-axis. So the y-axis, the x becomes opposite. So it was negative 4. It's going to become positive 4. And the 7 remains the same. And this would be what our a prime prime would be. Now, if we go back, it's 4, 7. Does that match our a prime prime? 4, 7, yes. So the answer would be B. So you would just choose B as your answer. Okay? All right. Let's go here. All right, we have one more to do on this one. The triangle A prime prime, B prime prime, C prime prime is shown on the coordinate grid. So A prime prime, B prime prime is shown, which means that this is the after. This is the image. This is after it was transformed. Okay? It says if triangle ABC was dilated by a scale factor of 2 with the origin as the center of dilation, and then translated using the rule x comma y, x plus 1 comma y minus 3 to create triangle A prime prime, B prime prime, C prime prime, which graph represents triangle A, B, C? So again, they're asking us which of these would have been the original. Which of these graph being the original that was dilated by a scale factor of 2 and then translated to give us this. So this would be the answer. So this is the answer in terms of the results. This is the result after the transformation. So we want to know which of these would have been the before. So we're going to have to work in backwards. Again, you always perform your transformation on the before. So just to make a note, this is the after. Okay? And the answer choices are your before. So let's highlight the transformation that took place. It says that triangle ABC, it was dilated by a scale factor of 2. And then it was translated using this particular rule. So two things took place. Dilated. So I'm going to write it here. Okay. Dilated by 2. Again, what does that mean? If you have a point X, comma, Y, you're going to take each of the coordinate, the X coordinate, and you're going to multiply the X coordinate by the number 2. This number 2 right here. Comma. And then you take the Y coordinate, whatever that number is, and you're going to multiply that again by the factor of 2, the scale factor. Okay? Now, translate. I'm going to write down a thing. We're going to translate yeah? And we're going to translate using the rule. So if you have the point X, comma, Y, when you translate, it's going to become the X number, whatever the X is right here, you're going to add 1 to it. Okay, comma, Y, whatever the Y is, you're going to minus 3. All right. So again, you do the transformation on the before. So do not pick a point from this. This is the after. This is the result after you would have done this. Okay, so we haven't done anything as yet. So you have to come down here and you're going to pick a point. There is 3 points or 3 vertices. Choose any one. Any one you're going to choose. So in this case, I'm going to choose point B. Okay. So I'm going to choose B. So if we choose B for this one, let me use a color. Which color did I not use? Let me use green. So we're only going to be choosing B. Okay. So for B, I'm going to use, this coordinate is 4, comma, 3. Okay. And then for this one, the coordinate of B is 7, comma, 3. For this B, the coordinate is 8, comma, 6. And for this B, The coordinate is 5, comma 0. Okay, so we're gonna take each of them until we get the answer. So we're gonna use, like, for example, this B, and we're gonna do this transformation, and we're gonna see which one matches B prime prime. So what are we looking for? So the answer that we're looking for, this is the answer that we want. So we want, this is the B prime prime, we want 9, comma 3. This is the key, okay? This is what we want. So we want 9, comma 3. So I'm going to start with the first one, the first graph. I'm going to start with this point, 4, negative 3. So where I'm going to write the point 4, negative 3. Sorry, did I say negative 3? 4, comma 3, I'm sorry. 4, comma 3. So we're doing this one, graph A. Okay, so 4, comma 3, if we dilate that by 2, the x coordinate is 4, so you're going to have 4. Then you're going to multiply the 4 by the 2, which is our scale factor, comma. And then the y coordinate is going to be 3. And then you're going to multiply that by 2. Okay? So this is going to be point B, coordinate B. So when we do that, our B prime becomes, what is 4 times 2? 8. What is 3 times 2? 6. So that's going to be our B prime. So now we're going to take our B prime, which is 8, comma 6, and we're going to translate it using the rule that they have given us to translate. So with that, we're going to take the x value, and the x value in this case, the x value is 8. And then we're going to add 1, then comma. You take the y, in this case our y is 6, and then minus 3. Now when you perform that, we're going to get B prime prime. So the B prime prime, 8 plus 1 is 9. And 6 minus 3 is 3. So if we use this B on this graph, this is what our answer would be. So we're going to go and see if that's what we wanted. Yes. See, we want 9, comma 3, and we have 9, comma 3. So notice that the answer would be the first graph, option A. So A, B, C, D. So the answer would be A. All right, I hope you have learned something. You can always go back to a point where, you didn't get, and replay it. All the best.